read the problem-solving oath, and if you pledge this, go ahead and type your name in the chat box.
So I started with 30 because I knew it was divisible by 6, and I got 5. You can see my guess and check table there. I knew it was too many, so I started with 18. And then I noticed that we had 3.
Real quick,
So I
how
noticed
did you
this
know
pattern.
it didn't work out? I missed that part because it looks like you have done the fractions correctly.
Correct. The fractions worked out great because of the numbers, but I knew at the end those 3 people had 6 M&Ms left, and that didn't work out with my numbers that were left.
Oh, I see. And we had 15 there.
There instead.
Cool.
Yeah.
All right, keep going.
So then I knew that was too big, so I went with a smaller number. So I started with 18, and I noticed the same pattern that no matter if I started with that number divisible by 6, that I still was getting the same amount for each person, and it was 3. And when I got to the last 3 people, there was 9, and again, I knew there was 6. So at that point, I didn't need to start with a number to guess and check. I knew that if each person the last 3 people had 2 and my pattern stayed the same, everyone should have 2. So then I just multiplied 2 times 6 and said there must have been 12 M&Ms to start.
So she started to see this pattern. And for everyone else who is listening, who can rephrase what was the pattern that she saw and how did that help her find the end number of M&Ms? Raha, go ahead.
So when she first started with her guess and check, she started with 30 M&Ms. And then as she noticed that the amount that each person was getting was 5, she noticed that she needed to lower her total number of M&Ms. That would lower the total number of M&Ms that people are getting in the story. Because, I'm sorry, at the end there were 4 left over and each twin got 2 and 2. So 5 and 3 wouldn't work. So she needed to keep lowering her total.
So this 2 and 2 is really important because it was the twins. Neat. All right, we're going to see how that compares to the green slide. If you all will come down to slide 34. This group did some really cool things, and what I want to focus on is this list. They have a lovely list here. And would you all take a peek at this list and a peek at slide 30 and tell us how are those two similar or different?
So I wanted to guess and check with starting with 24. And I noticed that in the previous slide, they also, there's a connection between 12 as being the total and 24 as being the total.
Well, to me, it looks like they both used a similar strategy and that they were guessing based on the quantities that were at the end. So they were using that end information, those numbers, the known quantities at the end to guess the total. So a guess and check strategy again. So they were using similar strategies, I guess.
Neat. So there's this idea of this end number. So let's go to slide 30 real quick. Let's talk more about this end number. If Raha were to put her method, that was the one on slide 34. If she were to put her method on this table, what do you think would be those circled numbers at the end? And how do you know? if we were to make another table where 24 was the end number, what numbers would be inside these circles, and how do you know? Stephanie?
I think inside those circles would be 4 because she was starting with 24 M&Ms. That is 6 less than the 30 and 6 more than the 18. And so it's like 24 is equidistant between 18 and 30, and 4 is equidistant between 3 and 5. So I think it would be 4 for each if we put the 24 to start.
That's really cool. I like the way that you kind of found this midpoint between the yellow highlighted numbers and the circled numbers. Awesome. Let's head down to slide 32 real quick.
So I drew the 6 boxes that are at the bottom of the slide. And I did that because it says Janelle wanted a 6th of it. So I thought it'd be easy to kind of see a visual. And so in the first box, I put Janelle, but she took a 6th of it. And then it says Tammy collects a 5th of it. And so I notice I have 5 more boxes. And so a 5th of that would be one of the boxes. And so that leaves me with 4 more boxes.
Hold on
and it
1
says
minute.
Jenny.
I think
Go
you
ahead.
just said
Yep.
that Tammy took 1/5, but she has the same amount as Janelle. Can you explain that real quick?
So she took 1/5 of what was remaining. And so she didn't take 1/5 of the whole, which is different.
Awesome. All right, keep on going.
Okay. And then Jenny did the same thing. She ignored what Tammy did. And so there's only 4 basically rectangles left, and that's the whole now. And so she took a 4th of that. And then there are 3 rectangles left, which are then the whole, and Samantha took a 1/3 of that. And then there are 2 rectangles left, and that's now the whole, and it says the twins shared the 4 M&Ms equally, so I put 2 here and 2 here for each of the twins. And so to me, that tells me each rectangle equals 2. So then I went back and I said, well, then Samantha has 2, and Jenny has 2, and Tammy has 2, and Janelle has 2. And if I add all those up, I get 12.
So that's kind of interesting about fractions, is Janelle had 1/6, but as soon as we took Janelle away, our fraction wasn't 6ths anymore. And now we're looking at it in terms of 5ths. And we could take Tammy's away, and then we would have 4ths and so on. There's another group who did something similar to this, and I want us to compare the two. So on slide 33, and I know you guys have 2 representations here, but I'd like for you to talk about the one with the arrow.
If there were 6 pieces, or, because I didn't know each one represented 2, I was like, well, let's just write one, make it easy. Looking at that denominator of a 6, then Janelle ate that 6, so then there's 5 left. So it's very similar. Tammy ate the 1, now there's 4 left. Jenny ate a 1/4 of what was left.
What is similar and what is different between slide 33 and slide 32?
In slide 33, they're representing the whole using pieces. And in slide 32, they're representing the whole as a linear model. But either way, part of each whole is represented with either a unifix cube or a box.
In slide 33, we have 2 yellows, but what does that number actually represent?
4.
So that's actually 4 M&Ms, even though it's
Right.
2 yellows. And so another neat thing that this group did over on the other side is they tried to be a little bit more concrete.
So we started down here with what was left. So we knew there were 4 left, and that now I forget who took the brown. Samantha took 1/3 of what was left. So from the brown down, that's, if you think of that as the first hole, Samantha had taken this 1/3. So this represents 2/3 of what's left. So, and we knew that was 4. So 4 was 2/3 of what was left before Samantha took hers. So we knew that, you know, these brown, orange, and yellows equaled 6. And here's 4. So the browns were 2. And then we kind of just worked from there.